My name is Dariya Roberts. I am a student at Penn State University, and I'm studying electrical engineering. Also, obviously, a Team 341 alum. I graduated in 2017, and I was on the team for all 4 years of high school. So I'm just going to talk to you guys a little bit about my experience on the team and some of the things that I gained and lessons I learned, and then how that led me to engineering in college and some of the things I've learned so far there. And I'm also going to talk to you about some of the major clubs I'm a part of at Penn State that you might want to join down the line. Okay, so I just wanted to start by talking a little bit about why I joined the team. I joined the team primarily because of my older sister, Dorian, who she graduated in 2012, I think. That's a picture of her on the left during her senior year and a picture of me on the right during my senior year. And she always spoke super highly of the team and enjoyed her time there and the friendships that she made. And thought that I might be a good fit for the mechanical team, probably primarily because I took a lot of things apart growing up, not necessarily knowing how to put them back together, but took a lot of things apart and worked with my dad a lot, trying to fix things around the house. So I had a little bit of experience with like power tools and things like that, but I didn't know anything about robotics. I just knew that I'd probably want to be on the mechanical team. And I'm really glad that I had her to tell me about the team, because otherwise, so many things about my life now would have been different, and I wouldn't have so many friends that I have now, and I definitely wouldn't be in engineering right now. So yeah, that's basically how I got into it. And then these are sort of like the highlights of the things that I did on the team. I was the mechanical build lead my senior year. So I did end up, primarily focusing on the mechanical build team. I primarily worked on that team all 4 years, but I also worked a little on the design and CAD side of things. I was the human player senior year, which was super cool because that was the year where you could actually be in like the center of the field while everything was like going on. So I got to be in the midst of like all the action and see the game from like a really unique perspective that I feel like a lot of people don't get. So that was a super cool position. I was a part of the pit crew for 2 years. I was a Dean's List nominee, and I'm also the creator of Touchdown Tumble, which I will talk to you a little bit about more in a minute. But yeah, so yeah, I was on the team for 4 years, 2014 to 2017. These are all of the robots that I got to be a part of. In 2014, I was a freshman. I didn't do that much. I tried to help where I could, but I was kind of just trying to like learn as much as I could. The Sparky's robots are like, I think, completely together now, but like back then, they were kind of just a lot of piles of miscellaneous metal. And one of the bigger jobs for the freshmen was to put those together. So I helped a lot with that, which got me super interested in mechanical because, the Sparky's robots have a lot of the design elements that end up going into the bigger robots. So it was a good Kickstarter. And I also distinctly remember helping a lot with the prototyping efforts. I helped with the team that prototyped the catapult, and that was just really cool. Like, it was really cool to work on that a whole Saturday and just like spend the whole day doing that. I don't think it worked very well, the one that I worked on at least, but it was really fun, and it got me really excited about mechanical specifically, and definitely excited about engineering potentially for the future. In 2015, I got a little bit more leadership, but I was working in a group that was responsible for prototyping the elevator for that robot, and then eventually I helped build the elevator a little bit that year. Yeah, 2015 was probably my least favorite year, just because I didn't like the game that much. A lot of people didn't like the game that much, but also that was one of the years that we probably didn't perform at like our best ability. But it's also a really memorable year for me because I feel like when that season was over, we had a lot of talks amongst like our own members and between members and mentors to sort of debrief on the season and what didn't go so well and what did go well, so that we could come back a lot stronger in the years to come. And I think the proof was in the pudding for that, because 2016 was like a really good year. That's like by far my favorite year because I feel like it was kind of like a comeback from 2015. And I also got to work on and help lead the group that was building the hangar that year. And I'm going to talk about that in a little bit, but that was like one of the my most favorite things to work on while I was on robotics. And 2017, I was a mechanical build lead. So I got to work on a lot of things on the robot that year, but primarily I worked on the gear intake and output, and also the ball intake. So I got to do a lot of different things. That was also the year that I was the human player as well and helped a little in pit. I feel like I got to, dip my toes in a lot of different types of components, and I learned a lot being on the mechanical team. All right, so let me talk to you about Touchdown Tumble. It's my little legacy piece. So Touchdown Tumble was this game that I came up with very quickly, right, like literally 15 minutes before my my end of the year evaluation for 2016, and I presented it to Coach Kara and Kier, basically asking them if I could spend the summer like developing it, to my best ability, to make a game manual, to make like fake game pieces and everything like that, and basically use it to present to the team to do like a mock kickoff in the fall, like right before the 2017 season. And they gave me the green light. So I spent a lot of the summer sort of trying to make my own game called Touchdown Tumble. So obviously it's football themed, and it was really fun. It was really fun working on this, and it was really fun watching it come to life, because we basically spent a large portion of the off season in 2016, pitching this to the team, strategizing for it. We had like a whole mock kickoff where we did the thing where like several members will like act like robots and play through different game strategies and match scenarios. And then we even broke up into teams, and we did CADs. We had a whole CAD critique where some of the mentors broke down some of the pros and cons of each team's CAD. And then from there, we also did prototyping. You can see some of the prototypes here, and they were really cool. And the goal that I had, I feel like I met. I wanted to get people really excited about the season, especially rookies, and I wanted people to, especially the ones who were new to the team, to get some experience building some of these design elements that like you pretty consistently need in first. Like obviously, First hasn't had a football themed game since Touchdown Tumble, and they might never have that, but First almost always has a game that requires a shooter, very frequently a flywheel shooter, and very frequently you need an intake as well. So we designed a lot of these elements that you need for different game pieces pretty consistently for First, so people were able to get experience in that. So yeah, I really like Touchdown Tumble. The only thing I will say that went kind of wrong with Touchdown Tumble is that I didn't have this like planned out in an airtight manner at all. I was kind of surprised that they gave me the green light to go ahead with this, because I didn't know what I was doing, but I didn't have a timeline planned out for like when it was going to end. I didn't know if we were going to end after the strategy portion or after the prototyping portion or the CAD portion. I didn't know if we were going to have a full football shooting robot at the end. I didn't know what the plan was. So a lot of people were asking me questions that I didn't know the answer to. So if you were ever going to do something like this, I would just say try to come up with a more concise timeline for how things could go and what you want to have learned and take away by the end. But I was also thinking about it, and like it would also make a pretty cool demo that you could take to like middle schools or potentially elementary schools, where you could, present to them some game that you've come up with and have them get a little bit of a taste of what it's like to experience kickoff. I don't know if you guys already do something like that. I don't know how the demos have changed, but like you could, sort of break them up into teams and sort of try to come up with a brief strategy for whatever the game is that you've created, and maybe they could even draw robots that they think would be good for that game. So I think it has potential. I think it was the beginning of something that could be really good, and hopefully, someone in the future does something even better.
Yeah, so one of the first challenges this year is actually to design a game.
Oh, really?
Yeah, so we're actually going to be doing this and having this, and one of our members last year actually designed a game too, based off of your precedent that you set with this. So we actually
so we actually have
2 like 3-4-1 games kind of in our our files here, and we'll be making another one starting on Saturday. So
All right, I like it.
yeah, it's
Yeah,
just
I think that like this experience that we had with Touchdown Tumble, just like from a coaching standpoint, like first of all, we let you do it because we were super psyched about it. We are like, yo, if some student wants to spend their entire summer doing this and then bring it back, like more power to them. We will run with it, and like as long as it's not like complete garbage. Like as long as it's like, we can run. Like if you would come to us with like half a field and no game piece and no rules, like it would not have worked out as well as it did. But when Dariya came back to us in the fall, she had drawing. She had like 75% of the robot kind of like fleshed out. I had like a real vision for it, and we were like absolutely blown away. And I think that the success of that is really what enabled Deep Sea Search, which was the game that was designed for last year. I think that like really enabled us to do more with Deep Sea Search and really give that a shot and feel confident that we could pull that off because we had done this. So this is definitely a really good legacy project.
Thank you. I appreciate that. That's really good information to know. But yeah.
Dariya, I kind of remember that meeting that you pitched this to us, because didn't you come in with like a full-size keyboard?
Yeah, I had spilled some liquids on my keyboard, so I had to have a separate keyboard and also a separate mouse.
Yeah.
I wasn't confident that I was going.
Well, you acted it, and that's all that matters.
Yeah, I had to go in there with some confidence and slam down my devices set up. But yeah. All right, so let's talk about 2016. So like I said, 2016 was my favorite year, and I wanted to talk about some of the lessons that I learned, and I feel like I learned some of the most lessons, both technically and like, just about myself and about the team through the 2016 season. So I kind of already explained, like 2015, it had some pretty low lows at times, and I feel like maybe I love 2016 so much because it had some really high highs. By comparison, we were winning a lot more, but I don't think that that's like a coincidence. I think it has a lot to do with the fact that we realized that we were doing some things wrong in 2015, probably both technically and like interpersonally, that we had to adjust a little bit. And to actually see the results of that was really fulfilling and rewarding. So I think 2016 was one of my favorite seasons because it kind of proved that like you can have a bad season, but it doesn't mean that like you're a bad team. Like you can come back from that type of thing. You can always come back from that type of thing. It's really just about your ability to adapt. And I also really liked that season because I got to work on the hangar. And we were just like my group that was working on the hangar, we received just an enormous amount of autonomy with that project. I think we worked on it for like the bulk of build season, which I'm not saying is like the most efficient way to go about building anything on the robot, but like we were given a lot of freedom to find out like every possible idea that we wanted to try and to try it. And even though there were a lot of stupid ones, we were able to sort of take like seeds of genius from each like dumb idea to finally get our end result. So I think we started that season off with the design that's on the far left, which is essentially just two massive pistons that we bolted to the robot. And I remember there was a lot of like disagreement about whether or not this was a good idea, but we were able to convince some of the mentors to help us actually hook it up and like make it work. And I think it took like 10 minutes to charge up, and everything was like insane. But if you notice on the picture on the bottom there, it did actually hang. It did work. It was just extremely stupid and probably not rule compliant. And so yeah, we didn't.
It wasn't budget friendly either. I think
no.
those cylinders was like really expensive.
No, it's just not a good look in general. So we decided to not go with that. But in our next design, I think we came up with so many things. We came up with like a rod that could like slingshot its way up onto the pole. We came up with like a grappling hook. But you'll notice that like in every design that we had, we sort of picked one element that sort of stuck with every additional design. So like in the first design, we had those pistons, and obviously we realized we didn't want like massive ginormous pistons like that, but we did end up using pistons in our next design for sort of a different part of it. And then in the second design, we had the winch, and the grappling hook idea didn't really work, but we did like the idea of using a winch. So then we had the winch and the pistons to move us to the third design, where we knew we needed these like really strong arms. And I think we had like hooks that had like holes in them or something, and the bars would sort of like slide through the holes. It was not right, but we sort of picked up the fact that we needed really strong hooks and we needed really strong arms, and that eventually led us to our final iteration, which I think actually was based on something that Adam came up with. He like sent us a sketch and he was like, you guys should try this. And his design actually incorporated pieces of, every design that we had made thus far. And I think we tried to make his design and we actually did it wrong. I'm pretty sure we did it like
I
backwards
was
or
just gonna
something.
say we did it entirely wrong.
Entirely wrong. Yes,
So
that's
this
what
was
it was.
when I don't think anybody here that's still on the team would remember this, but Adam used to only be really with us in person on the weekends because he lived at Penn State. Adam has since moved back to the area, Dariya, so
Okay.
he's now local. But so Adam put this design on the forum, and then we sat down the next work session, which was during the week, and we were looking at this like, okay, so we think it works this way, and we built
Right.
it like entirely not what Adam had suggested,
Entirely.
but it ended
Yeah.
up being what worked for us.
Yeah. So we thought we built it correctly and we tested it. And as you can tell by like the photo in the center, I was really happy because it kind of worked. Like it kind of worked. Like basically the arm was able to like flick itself up in the way that we had intended it to. And that was like a really big moment. And I'm pretty sure he came in and he was like, this was not what I intended, like what I thought we were going to be, what we were doing, but it did end up working. And we kind of just went with it and kept trying to make that one design work. And it did end up working. And it was really sick. Like we went to competition that year at Hapro, and I'm pretty sure we were like the first robot to hang that day. And I'm telling you, it was pandemonium in that event. I'm telling you, it was so cool. Because our hanger was like really obnoxious. Like it was super loud and forceful, and like you would hear it just like slap its arms up against the bar, and you'd hear the hooks like pull back on the bar, and then you'd hear the winch rev up, and the ropes would start tightening, and this 200-pound robot would start lifting. And when that happened, we just about shut Hapro Horsham down. I'm telling you, it was so cool. It was like by far one of my most memorable experiences on this team. And like, had we not gone through all of those like smaller, less efficient ideas, I don't think we would have come to, that idea. And I feel like I got to learn a lot in that process, and it was really rewarding watching it play out. Yeah, it just never got old watching that robot hang. I'm not saying it was the most consistent, but like nobody had a hanger that was like ours, and like most of the time it worked, and it was really cool to watch. Let me see. Okay, so I wanted to talk about some of the general things that I've gained from the team. Sorry. So, when I joined as a freshman, I didn't know anything about FIRST. I wasn't a part of FLL or anything like that. I really didn't know anything about robotics in general. And I just knew that I liked to build things, and I really liked to listen to the upperclassmen because they seemed really, really passionate about what they were doing. But when I would initially talk to them, I had to Google like every other thing that they said to me because I genuinely did not understand what was going on and how they knew all of this information. Like the gap between the amount of things that I knew and what they knew was so large. I was like, I don't think I'll ever be at that point. But I think the most important step is genuinely to show up. Like I know a lot of people probably say that, but it really works in ways that you don't understand. Like you start learning things just by being there that you're not really even cognizant of the fact that you are gaining that knowledge. And before you know it, that gap starts to close and you know just as much as them, if not more. And I feel like I'm kind of proof of that because I'm telling you, I did not know anything coming in, and the fact that I was able to become mechanical lead was something that I didn't think was ever going to happen, but I just kept showing up as much as I could. So if you don't know what you're doing on the team yet, if you're a rookie or something like that, and you feel very lost, just show up as much as possible. Show up anytime that you have free time and try to learn as much as you can while you're there. Because before you know it, like you're going to know what you're doing as much as anybody else does. And the second thing I wanted to say is that there are no dumb ideas. You know, that's sort of proof in the whole hanger scheme, but like genuinely, I think you have to throw out as many ideas as you have and not worry too much about what people think and not worry if you sound stupid. I don't think anybody there is judging you. Like, honestly, I think everybody has the same goal and everybody just wants to help you. So, you know, toss out those ideas because most of the time in all of those dumb ideas, there's probably a seed of like genius and you're getting closer and closer to a really good one. Also, you might think an idea is stupid and it's actually really, really good. And it's what was the key and what we needed or what you needed as a team. So just continue to throw out as many ideas as you can and don't overthink too much about whether or not it's too stupid or something like that because it's probably not. And you got to have self-confidence. You know, I feel like I gained a lot of self-confidence on the team. I feel like I was really, really quiet at first, but you have to have self-confidence in order to talk about the things that you like and the things that you don't like and the things that you want to change or what's going well and what isn't. You also, I definitely feel like in Pitt, I had to have a lot of self-confidence talking to judges about the work that I did and also the work that we did as a team, you know, confidently and passionately. And that's a self-confidence that you're going to have to carry, I feel like, into the rest of your life. You're going to have to be able to speak up and you know, speak for yourself. So try to you know, start doing those things now because it's going to help you on later on in life. And then the next point definitely I think is the same. You have to have the ability to take constructive criticism. Man, I was critiqued a lot on the team. I feel like there were definitely times where, you know, I think I let like my ego get in the way of things and I was like really dictating like a lot of the groups that I was working in and I didn't even realize it. Like I honestly thought that like at all times I was a pretty good leader, but I got critique from like other members. I got critique from mentors and there were times when it like really stung. But like looking back, I'm like, oh, I definitely deserved that. Like I needed that because it was what I needed to be able to like reevaluate what I was doing and become better. And I get critiqued all the time now in engineering. I just like expect it now because I know that I don't know everything. And that makes it a lot easier for me to like, you know, humble myself and like make the changes necessary. So you got to get good at that. You got to get good at like knowing that you don't know everything and people are just trying to help you when they're telling you something that you should change. And then I definitely walked away with a lot of design and build skills because when I left the team, I was pretty sure I wanted to go into mechanical engineering. And I had, because I just spent 4 years on the mechanical team. So I walked away with a lot of skills that are like really good for that field. You know, I knew how to problem solve really well. I knew how to work in a team really well. I knew how to use like a bunch of tools and machines and things like that. And I also had some important like software skills. I had learned how to CAD, and that was like one of the most important like actual technical things that I learned on the team. CAD has definitely been the thing that turned out to be like one of the most important things that really comes in handy often. I wish I had spent more time programming as well because like being in engineering now, I see like how important it is. But I would just say if you're planning on going into engineering at all, any field in engineering, learn how to CAD now and learn how to program now as much as you can. Like take advantage of those licenses, take advantage of that coin that you don't have to spend. Like do what you can now because like down the line, it's really going to help you in a lot of ways. Obviously, I'm not gonna get too cheesy, but I got a lot of lifelong friendships from this team. I mean, I talk to people that I was on the team with like every day, and I see them all the time. And like, you know, these people are gonna be at my wedding. They're gonna be people that I'm talking to for the rest of my life because I just, you know, you really bond with these people, not just because you're there so often, but also because I feel like you get pushed into these situations where you have to solve a problem with them and learn to work well with them. And yeah, I'm really grateful for that. So try to like make as many friends as you can while you're on this team because they're the type of people that are going to be there honestly for the rest of your life if you want them to be. And then cherish this time. That kind of ties into the same, you know, idea. But like I'm telling you, I've been on a lot of teams since, and I'm sure I'm going to be on a lot more. But like there really is nothing like being a student on a first team. You know, when I first got out of high school, I tried very briefly. It's kind of a long story, but I tried very briefly to mentor for a robotics team that's near Penn State, and that was like I quickly realized it's a completely different experience. Like you get some of that nostalgia and that's really cool, but like that feeling that you have as like a student that's actually like kind of in control and gets the problem like tossed at you, it's like a very different thing. And you're not going to feel a feeling that's exactly like that maybe ever again. So I would just, take advantage of this time and don't walk away from the team with any regrets. Do as much as you can and throw out as many ideas as you can while you are here, because like, it's not going to last forever. And then stay hungry. I just wanted to make this point because like, Team 341 has had some really good years and it's had some, maybe not so good years, but like I think the best years are probably still to come. Like there really is no difference between you guys and like a team like 254. Like you can go to Einstein every year if you want to go to Einstein every year. You just got to stay hungry, don't get comfortable, you know what I mean? Like keep that W in mind at all times and constantly reevaluate, yourself personally and the team as a whole. And try to keep adapting and changing and making yourself better. Stay hungry. So yeah. All right, so I wanted to talk a little bit about a typical semester for first years in engineering, but obviously I have to give some context because I go to Penn State and not everybody in here is going to go to Penn State, and I don't know if it's like this at every school, but I think it's kind of generally like this when you go into engineering. I kind of mentioned this before, but originally I was on the intended major track for mechanical engineering. So that ended up changing, and I'm going to explain a little bit why later. But when you go into engineering, these are some of the like courses you're going to take as a freshman. You usually have to take a math course. It's usually Calc 1 or 2. You have to take a physics course, a chem course, and you got to take English because you still need to learn how to, read and write. And you also have to take a first year seminar. And this is pretty much, at least at Penn State, the only thing that is different in terms of the classes you're taking between like the intended majors. So everything else, pretty much, no matter what your intended major is, you're taking the same. But for me, because I was on the mechanical track, my first year seminar was eDesign 100. And this was like the first indication that like I had learned a lot in robotics without even realizing, because so much of that class was just about learning how to design things and take things from an idea to reality, and specifically teaching you how to CAD. And so many projects I was able to finish so much quicker and so much easier than the people around me because I already knew how to CAD from robotics. And that allowed me to spend a lot of extra time on them and make them look really nice. And it was just like a lot of fun. And that was a class I did really well in, honestly, solely because of the knowledge that I got from robotics. So I wanted to show you, some of the projects that I worked on during that time. This is a project we got where I had to design an entertainment system. I mean, I love my entertainment system personally. I still love it. I'd put that in my own home, but that was mine there. We had to CAD that and we had to create a manual for how people would put it together. So we had to make individual parts for it. That second one was an interesting project. That was, we had to design a dumpling maker, and my dumpling maker looks more like a robot than a dumpling maker. And that's primarily because like back then I only knew how to CAD like robot-like things. So I remember like I sent it to a bunch of my robo friends and they were like, that looks like a Symbotics robot. So, but I was proud of it. I like my dumpling maker. And then, and the final project we had that year was a design competition that was sponsored by Lockheed Martin. And it's like a really big project. And basically we were supposed to design like a multi-driver. So you have to design either a tool or like a machine or something that can take out multiple screws at once. And my team ended up deciding that we wanted to create something that was really easy to manufacture, and also something that could just be like an attachment to a power tool or machine that like a lot of people probably already have, like a hand drill. So yeah, this was our design. We, spent a lot of work on the CAD and like trying to make sure it actually could work in real life. And then we got to the prototyping portion, and I learned that at Penn State, like prototyping as a freshman in probably a course that already has a very limited curriculum means a very different thing than it means on robotics. So prototyping, I mean, that upper right corner picture is my prototype, or my group's prototype of my dumpling maker. And that was sort of frustrating to me, because at that time, you know, coming off of robotics, I was taught that, like, when you build a prototype, you should walk away having learned something from it and having gained knowledge about your design. And so it was kind of frustrating to me that, like, prototyping at that time kind of just meant, you know, gluing together some cardboard and stuff like that. So I tried to convince my team to actually try to build our design, because we had a lot of extra time. And they were like, if you can come up with the parts, we can build it. Because at that point we were already going to get like an A, so they thought I was being a try hard. I probably was. But I ended up finding the parts, and we printed everything that we didn't have. We 3D printed everything else that we didn't have. And we did end up building it. And we did it in front of everybody. We were able to actually, like, turn it on. We didn't unscrew anything because it would have fallen apart, but it was like much better and like much more advanced than like all the other prototypes. So it was really, really cool. We ended up winning the competition, and yeah, that's my group right there. The guy in the middle is actually holding a hand drill with our prototype actually inserted into it. So yeah,
Okay,
that was really fun.
wait, are those orange urethane belts?
Yeah. Okay. So listen, we ended up going with different belts. Okay. So we don't use those orange belts from robotics. That was just sort of a concept type of thing. We used like this different belting that you use on like a 3D printer. Have you ever seen the, like, yeah, we
Yeah,
used
yeah.
those. Yeah. So I'm not saying that I would actually make this, but we won. So that's all that matters. Anyways. Um, All right, so this slide is about why you should choose EECS. EECS stands for Electrical Engineering and Computer Science. I don't know if they do this everywhere, but at Penn State, they tend to combine the two a lot because there's a lot of overlap between those two majors. But I also should talk about why I chose Electrical Engineering and Computer Science. So like I said, I was on the mechanical track for 2 years. I really thought that I was supposed to be mechanical and that I wanted to be in mechanical, but I started struggling academically sophomore year a lot. And was definitely um, that was definitely primarily because of myself and like the way that I was used to learning and teaching myself things and studying, and I was not adapting to like the way that like college was different than high school. Like I used to cram a lot of information. I used to be really good at cramming for tests and things like that, and I studied on my own, and I didn't ask a lot of questions, and I kept my head down, and I started to realize that like it wasn't working for me at all, but I wasn't really making like, you know, the changes necessary to become a better student at all. Like I was just telling myself I wasn't like working hard enough. So if I like didn't do very well on an exam and I had studied like 10 hours for it, I'd be like, okay, well, you just have to study for 20, the next one. And I'd fail it again and I'd be really disappointed. And that loop just kind of kept going on and I wasn't really doing anything different. So by the end of my sophomore year, I had completed all of the like required entrance to major courses that were necessary, but I came like just short of the GPA requirement, and like I was like devastated because I had to completely recalibrate my life and my goals, and you know I had like a mini existential crisis where I was like, oh, I don't know what I'm supposed to do, and you know I got to spend I got to spend the summer, luckily, like thinking about, you know, what I was doing wrong and like what I wanted to do for the rest of my life, because essentially my options at that point were to like transfer to a branch campus and I could still get my MECE degree there, or I could transfer schools altogether and get my MECE degree there. But or I could change like majors altogether within the College of Engineering or not. So, you know, I had to spend a lot of time talking to my family and my friends and reading a lot of Reddit posts and talking to an advisor. And basically, I realized that the things I really liked about engineering were like I really liked to design things and I really liked to build things and I really liked to problem solve. And it had always kind of been my goal to go into a field related to mechatronics. So I always kind of wanted to get knowledge in both mechanical and electrical and a little bit more programming knowledge. I didn't really ever intend to just strictly do mechanical. So I spoke to all these people and essentially realized that like I could still do all of the things that I wanted to do without being in mechanical, specifically by being in electrical. So it was a really big change and a really big step and risk. I didn't know if I was going to like it. I really didn't have a ton of electrical experience at all. And the courses for electrical are very, very different from, especially in the beginning, than the courses for mechanical. I had just been taking all of these courses about like force analysis and things like that. And now I was having to do circuit analysis, and it was like a complete 180. So, but it was a great decision. Like now looking back, I'm like really, really happy. First of all, because I actually really like electrical, and I've gotten a lot of opportunities that I wouldn't have gotten otherwise being a part of electrical. But it's also a really good experience because it forced me to change the way that I was going about learning and being a student. And it forced me to start asking for help, to start going to office hours, and to get tutoring when I needed to, and make friends within my major. It really forced me to buckle down and like realize that like if I didn't get it together, like I wasn't going to reach my goal. So that's why I chose EECS. But in general, if you're interested in electrical, it's a really, really good major. You get to do a lot of hands-on problem solving through like circuitry and things like that. It's also really highly in demand right now. There's a wide range of sub-disciplines. With a 4-year degree alone, you're going to be able to get a lot of really good jobs, which is nice. And that second to last point is the one that was most significant for me, but it's so closely related to so many other engineering disciplines. It's so closely related to computer engineering, computer science, mechanical. So you really aren't like pigeonholed into just the field of electrical engineering. You get to do a lot of other things with that one degree. So it's a really good major to go into, and I'm very happy that I chose it. Yeah, so now I just wanted to talk, I wanted to tell you about this as well, sorry. The pictures on the right are actually from, I wanted to explain to you guys like some of the projects that you get to do for electrical as well. So I know I just talked about some of the mechanical projects you get to do in class, but this is a really cool project I recently got to do for one of my EE classes where we were basically designing a key fob. And this is really messy because I was just starting to learn how to, work with breadboards and things like that. This isn't how they should really look. But you know how like with your key fob, you have like a lock button and unlock button. Sometimes you can pop the trunk and things like that. This circuit does that. And we basically got to completely design it from scratch. This whole design, we carried it through like several iterations where first it was just like a simulation on the computer. And then we had this really messy circuit. And then by the end, we had this much cleaner circuit that used what's called like an LCD screen and a microcontroller that you can program to do most of the functions that all of those other gates can do, so you can just replace them. And it was really, really cool. It was a really cool practical example of something that's at a circuit that's necessary in the real world that we got a lot of hands-on experience with in class. Yeah. You don't get to do that for like every, I guess, engineering discipline. So that's just one of the things that I really like about EE is that it's very hands-on. All right, so I wanted to talk to you guys about some of the clubs I'm in at Penn State. And the first one I want to talk about is Penn State Formula Racing. So I don't know if you guys know about Formula Racing. I don't even know if you know about F1. If you don't, you should go on to Netflix and watch this docuseries called F1 Drive to Survive.
It's amazing.
It's so good. It's really, really good. It'll get you super excited about F1. I'm telling you, like it tells you all about the politics and like, the money and also the cars and the drivers and things like that. When you understand those things, you'll understand like why F1 is such a big deal in some parts of the world. But F1's really cool. And for Penn State Formula Racing, it's basically a club that's a part of this design competition that happens globally where all these colleges all over the world work to design and build a formula-style race car, and then we compete against one another. It's a lot like robotics in that way, and it's also like robotics because basically in order to produce this one car, we have to break up into a bunch of subsystems and a bunch of sub teams. So we have like an aerodynamics team, we have a chassis team, we have a suspension team, a powertrain team, an electrical team. We have an administrative team, which basically helps with all of our PR and our website, and also, everything media related, and getting us like sponsorships. So everybody plays like a really pivotal role in eventually producing this one car, just like it is for robotics. So it's a really cool team. I've been on this team for 4 years, but I really started coming in a lot and doing a lot of work during my sophomore year. So again, at that point, I was still on the mechanical track. So I was doing mechanical related work a lot more than anything else. And I got a lot of jobs. I was primarily working on the powertrain team because that's usually what you do when you're in mechanical most of the time. And the powertrain team works on all of the projects that are like engine related. So I got to be a part of some really cool projects. I designed our exhaust one year. I started the process of researching and designing a muffler. I designed and manufactured one of our fuel tanks one year. And because of like my CAD experience, I was given like a lot of jobs and a lot of CAD related jobs. Like one year, we use like what's called a Yamaha R6 engine. It's usually used on motorcycles, but Yamaha is like legally not allowed to give out their CAD files. So we were doing a bunch of custom work on the engine, but we didn't have any evidence of this, and we couldn't represent that in our full car CAD. So we had to assemble a team that had to start slowly taking apart the engine and CADing really meticulous like pieces of it. And basically that was like part of the group that I was on for a while. I had to CAD, you see like all those gears at the bottom, those are the gears for shifting that are inside of the engine, and I had to CAD almost all of them. So it was fun though. It was honestly like I started to really enjoy CAD, and because it's one of those things you can just like sit up and do while you watch TV or something like that. I don't know, I do, but I got to enjoy that and be a part of those teams. But it's a cool team. There are a lot of like social events. There's a lot of parties. Even like remotely now. This coming weekend we're having an Among Us night. So that's what that like flyer is for. We're doing like a bunch of remote things as much as we can. But yeah, it's a good team. And also, if you want to work in the automotive industry, I know for a fact that like a lot of companies are looking for students that are a part of Formula. I didn't even apply I just had an interview with Ford that like I didn't even apply to, but they got my resume from Formula, and I wouldn't have applied to probably because I never saw myself working in the automotive industry, but they are really looking for kids that have this experience, because I think a lot of these kids are really interested in cars, and they're looking for kids that have this technical experience as well. So if you want to work, on cars for the rest of your life, this is a great team to join. Like half the seniors that graduate end up working for Ford or Honda or GM, one of those companies. So yeah, I would definitely recommend you do that.
This is amazing. Can I join?
I'll ask.
I want to quit my job and work for an automobile maker.
I'm not a car person, like personally, but I have like I didn't come onto the team knowing anything about cars, and that was really like kind of jarring, like because so many of the kids on this team are specifically car people. But you just keep going and you keep learning. It's like robotics, and now I definitely appreciate cars, if nothing else. Like I do find it really interesting what I have gotten to work on. So yeah, it is really cool. But yeah, this year is really cool because this year I am one of the electrical leads for the team. I am the low voltage lead. There's two electrical leads. So there's a low voltage lead and there's the high voltage lead. And that's because this is our first year attempting to build a fully electric car. So it's a pressure filled year to be an electric lead. But it's a really cool thing to do. A lot of teams are trying to do this now, and we've just been trying to assemble the budget for it, and finally we can attempt to do it this year. So when you build an electric car, you sort of split up into these two sections, because there's the high voltage side, which handles like designing and building the battery for the car, the battery management system, motor controllers, and then the massive motor that's going to actually run the car. And then there's the low voltage side, which I'm the lead of, which consists of pretty much everything else on the car that's related to electronics. But specifically, like my biggest thing is that I have to make a lot of custom circuits to basically guarantee the safety of the car. So there are a bunch of circuits that I have to design and eventually print that can test for a whole bunch of dangerous situations. And if they're happening, they shut down the car automatically. But I also work on the wiring harness, which has like all the sensors for the car and the ECU and everything like that. And I also can either design or buy the dashboard. And yeah, that's a picture. The picture in like the top right is a schematic for a circuit that I'm working on right now called the BSPD. And it basically tests whether or not the driver is like fully braking the car and also speeding up the car, because like that's not supposed to happen and that can be dangerous. And if that's happening for more than like half a second exactly, then the car is supposed to shut itself down. And it's really, really cool that like all of these small little electrical elements are able to tell all of those things and eventually shut down the car if that's happening. So that's the schematic for it up top. And then on the bottom, that is a very, very early version of the PCB that we're starting to design now, and we're hoping to print by the end of break. It is not right currently, but those are all the pieces for it sort of laid out. So yeah, I'm also part of IEEE. I'm the outreach chair for IEEE. So I get to, do a bunch of presentations like this for high schoolers and middle schoolers talking about engineering, and specifically electrical engineering. So IEEE stands for the Institute of Electrical and Electronics Engineers. It is basically a technical professional association. So you can be a part of it after you graduate from college. It's also the largest technical professional association, so probably the best one as well. And on the Penn State chapter level of IEEE, it's basically an organization dedicated to furthering the education of students. And we do that through some of the things that are listed there. It's really good because it brings together a lot of people that are within the same major and have the same goals, and you get to like work with them and learn a lot from them. And it's also going to help you, link up with a lot of really good companies, hopefully, raise your chances of getting an internship and eventually a job in your desired field. So we have technical workshops. This is like one of the coolest parts of the club, I feel like, because the thing you kind of have to understand is that like when you're trying to get a job, I don't know if it's always like this, but my understanding is like when you're trying to get a job, the most important thing is not to necessarily have had like an internship every year of college. Like it's more just you have to have something to talk to them about. And this club really quickly gives you some great technical experience that you can talk to them about. Specifically, we're going to teach you how to use a breadboard. We're going to teach you about circuit analysis, how to use an Arduino, the difference between like an Arduino and a Raspberry Pi, and how to use that as well. Designing your own PCB, the like BAT PCB and the ornaments are both like workshops that we recently did. So we teach people how to design those from start to finish, and then you get to obviously walk away with your own. And then we also have some programming workshops where we teach people some of the basics of Python and MATLAB, because you have to use those a lot for EE. So yeah, it's really cool for that. You get to directly apply some of the things that you're learning in class in a very fun way. We also have social events, and this is a big thing because like engineering is not all work and no play. Like IEEE tries really hard to bring together people in a way that can still be fun. We have intramural teams, and we also have like study groups, and we participate in Thon, and just like Formula, I feel like IEEE has been trying really hard to adapt to the pandemic and still do things remotely, and we have a lot of fun. And yeah, I've made some of like my best friends within my major through joining IEEE. And they are the people that like I feel like I can go to with academic help whenever I need to. You want to join clubs like this because you don't want to be up at 11:50 on a Friday night with a lab due at 11:59 and no one to text. Like that is a bad situation, and I've been there many times. So you have to join clubs like this, and you have to get familiar with the people that are doing similar things as you. I'm also part of SWE, which stands for the Society of Women Engineers. That's the mission statement for SWE, but to sort of summarize what SWE does, they try to bring together women that are within STEM and engineering, because obviously, unfortunately, engineering still very much skews white and it still very much skews male. And actually, women only hold 24% of the nation's jobs in STEM. And that's a pretty poor percentage. I really like being a part of Formula, but of the like 100 members we have, about 60 of them are like really active and end up going to competition. And of that 60, there are only 4 women on the team. Of that 4, I am one of 2 that are actually pursuing engineering degrees. So you can really feel, you can feel the effects of it in your classes and in your clubs. It can sometimes feel like there aren't any other women that are pursuing the same goals as you, but joining SWE has definitely opened my eyes to the fact that there are a lot, and we're trying to definitely get more to join SWE and more to be excited about engineering. And these women, like being a part of these societies, are really important because these women really want other women to succeed and are going to go out of their way to help you both with your classes and also to secure a job down the line. It's a really good society to be a part of. And it's another one where you can be a part of it after graduation as well. Like you don't have to just be in college. You can be in this for the rest of your life. So yeah, and also SWE is really fun. I'm a part of SWE, but I'm one of the chairs for I'm basically the Technology Initiatives Outreach Chair, which basically for that job, I'm helping them currently start a YouTube channel and start a podcast. So I get to interview a lot of alumni that were a part of SWE about the jobs that they're doing now, and members that are currently a part of SWE about some of the experiences that they've had being a woman in engineering. And it's really cool. So you don't have to just do an engineering related thing being a part of SWE. I'm more on the audio video side right now. All right, so this is, I think, one of the last things I have to talk about, but I wanted to talk about summer work / internships / research. So I actually have only had one internship in all of my time at college. I had one other one I was offered when I was a sophomore, but I ended up needing to go home and help my family out with some things and work that summer. So the only internship I had was summer of my junior year. That's this past summer, but it was a really, really fun internship. And basically, I initially had an internship with a different company, but it got canceled because of COVID. And Penn State was doing this thing where you could apply to be a part of this internship. And if you got accepted, you'd get paired with a group and also either a company or a professor to do something. And you didn't really know who you were going to get paired with or what you were going to do. But I was like, I'll just take it, especially because it was paid. So I just took it. But I applied. I ended up getting accepted. And I got put into this group with 3 other guys, and all of them were mechanical engineers. And we got put with a professor that was super nice. And basically, our whole internship was to help him design a UGV, which stands for Unmanned Ground Vehicle, that was capable of doing work in an orchard. So basically, in the end goal of the project, there would be a LiDAR camera that would be strapped to the top of the vehicle, so it could roll its way through orchards and scan the fruit for its conditioning, and maybe potentially later on be able to actually harvest it. It had to have a hitch on the back so that it could mow and also spray, and try to replace all of those jobs that humans have to do in an orchard. So we didn't have to do a ton of the deep programming and like electrical work, honestly, because he kind of had an idea of what he wanted to do with that, because he started that aspect of the project with some grad students. He just wanted us to focus on, you know, the skeleton of it and a couple of the really important electrical aspects, like, you know, the batteries and the motors and things like that. So we were given a lot of autonomy with this project. He basically told us like a list of like 5 things that he knew he wanted. And beyond that, he wanted us to like, you know, show him like what all of his options were. So it was a 10-week internship. The first 4 weeks were basically a design competition where each of us had to come up with our own design based on research that we were doing. And then the 4th week, we presented it to each other and presented it to him. And we were supposed to treat him like a client, basically, and take his input. And we prioritized like the things that he really wanted and ranked each design based on that. So actually, my design ended up getting picked, which was really cool and validating, obviously, because like I was the only electrical person, and I was still able to kind of hold my own with some mechs there. So we went with my design. I love this vehicle. It's my baby. We called it Appa. And basically, we spent the remaining 6 weeks trying to further develop it. And again, we were treating him like the client. So each week we'd present him with like a memo of everything we'd done. And he'd usually have notes, and he'd be like, oh, I don't want 6 wheels anymore. I want 4, or I want to be able to weld the frame together. So you need to make it with like this type of tubing, or make it this way. And he'd just have little notes that each week we'd kind of try to change the vehicle for, and refine like constantly to his desires. And yeah, again, it was really fun. And I learned a lot about engineering in this type of way. And I feel like it was the perfect internship for me at that time, because it was everything I wanted in terms of like the mixture of like mechanical and electrical, and getting to work on both of those things. So yeah. And I just wanted to show this screen because, like the hangar from years past, this vehicle went through so many different iterations before we ended up with Appa. I started off, and these are just my CAD designs. This isn't even like all of my group's CAD designs, but this is every design that I think I made that summer before ending up there. And some of these look ludicrous, and I don't know why I thought that they would work. The one that actually got picked was, I think, the green one, the dark green one in the upper right corner. And that looks so different than what we ended up with. But it was the drivetrain that was the biggest thing. Like, they really liked the drivetrain design that I had. And so we kept the drivetrain pretty much the same. And we basically started changing a lot of other things about the frame and the layout and things like that until we reached the end. All right, so this is my last slide. I know I've probably been talking for an absurd amount of time. When I started this presentation, there was natural light coming in the room, and now I'm just about in the pitch black.
No, you're good. You're good.
Okay, so I just wanted to end this talking about some of the things I've learned in college so far. And I say so far because upon switching from mechanical to electrical, one of the things that ended up happening was I got a little bit behind. So I have actually, I'm not going to graduate until the fall. So I have an extra semester. And, you know, I learn something new about myself and about college, I feel like, every day. So in 2 semesters, I could probably do like 2 whole, you know, presentations for you guys. But this is what I think has been most important, and the things that I have really had to learn so far, mostly. So the first one is that no one can do it alone. So, you know, when I take myself back to like my freshman and sophomore year, where I was struggling a little bit, it was definitely primarily because I was trying to do everything on my own. Like, I was not branching out, and I wasn't speaking to my professors, and I wasn't getting help when I needed it. And, you know, I look at like a lot of my friends that were on the same track as me that did end up making it into mechanical. And it's not that they were like vastly smarter than me. It's just that they realized that point very quickly. They realized that like you are so much better working with other people and getting help from other people and working as a team than you are on your own. And honestly, I know Penn State does this. I don't know if every college does this, but they give you a workload that's so large that you honestly realize you have to start working with other people. Like, I'm pretty sure they're trying to force you to understand that, like, in the industry, you're going to have to work with other people. So it's something that you have to realize really quickly. And when something isn't working, I get to this point a little bit later, but when something isn't working, you have to be able to adapt and change. Like, don't keep doing the same thing over and over again. Now, like, I work with so many other people when I'm working on assignments that are really big, and I'm so much better of a student for it, and a better engineer for it as well. Um, and a lot of things, yeah, the second point, sorry, a lot of things seem like they're the end of the world, but they aren't. I think this is important to remember. I definitely feel like I've failed quite a few times in college. I've had a lot of shortcomings, and the most important thing is just to remember like why you're there, and to not lose sight of like your goal, because like you're not going to succeed at everything. Like, not everything is going to go exactly as you plan. Like, I'm sure you guys are really smart, you're probably better students than me, but like, still, most likely you're going to find yourself in situations where things did not go as you planned them to, and sometimes it really seems like that's the point where you should give up. Don't give up, because most of the time there is a way out, there is a way around. You know, I'm going to hopefully, get the opportunity to still study mechanical down the line. In speaking to my advisor, I'm attempting to go to grad school for mechanical, actually, so I can still hopefully work on the mechanical side, just having had to get my electrical degree. And back then, when I found out that I didn't make it into mechanical, I thought that was the end of like my future in mechanical permanently. It doesn't have to be. And you just kind of have to remember that you have to find a way around. And that sort of serves to the next point, which is like, you got to be able to adapt, not just to failures, but also just to changes in general. Like, you can't treat high school the same way that you treat college. Like, it's different, and a lot of things are going to change, and a lot of things are going to be like on you now. You know what I mean? That one of my points was to take control of your own life. I say that because like, you're in control of so many things in college. Like, you're in control of your finances, you're completely in control of your schedule, you're in control of, whether or not you go to class that day, and no one's gonna track you down and say like, hey, you were supposed to be there. You know what I mean? Like, you're just gonna, but you are gonna see the consequences of like every decision that you make. You know what I'm saying? So you are in control of those things, but you have to remember like why you're there and what you're trying to accomplish, or you can veer off track a little bit. And then I make a point where I say you have to trust yourself. And I think that one's important because, especially when I didn't make it into mechanical, but definitely times even before that, I found myself questioning a lot whether or not like I was supposed to be in engineering at all, and definitely in mechanical. And man, I was struggling as a freshman with Calc 2, and my advisor was pretty frank with me. She's like, if you're struggling in this class, you are going to be struggling for the rest of your time here. Like, I don't know if you're supposed to be here, but that kind of lit a fire under me to work like a lot harder and to prove her wrong. And I think it's really important to trust yourself and your own judgment about yourself. Don't let anybody else decide for you like what you are capable of. Like, you have to make those decisions. And yeah, like, you're not always gonna, I think you're probably gonna question a couple times like if you're in the right place, but you have to remember like why you're there. And for me, it was remembering like robotics, and remembering why I chose this path in the first place, and what I had done well up until that point, and that's why I'm still sitting here. And I would just say, if you're miserable in your major, like genuinely miserable, and you've been trying everything, and you've given it a genuine shot, then it's like, that's a different thing. Like, then you should trust yourself as well, in potentially switching and doing something different. Like, there's nothing wrong with that. But if you know that you can do it, don't let somebody else like tell you that you can't. Um, and then I make the point, like, learn to celebrate yourself as much as you hold yourself accountable. Like I said, like, don't fixate on the things that don't go well. Like, try to remember the things that you've done really well. Try to remember the positives. If you went to all your classes one week, like, that ends up being a big accomplishment towards those later years. So try to remember those things, and celebrate the little things. because just like robotics, like college doesn't last forever. So you want to cherish every moment and definitely cherish every victory, and then stay hungry. You know what I mean? You got to stay hungry in everything that you do. You gotta treat the rest of your life like you're trying to reach Einstein. You know what I mean? And in everything that you're doing, not even reach Einstein. You're trying to win the world championship, obviously. So, constantly try to one up yourself. As a person, try to one up yourself, like as an engineer. Keep challenging yourself because it is going to make you better. So yeah, continue to stay hungry. And then I was gonna put, take any questions. I know it's been a while, but I'll definitely take any questions. And I put my email there if you have any, additional questions about Penn State or any of those clubs that I'm a part of, or just anything I talked about. And those are the QR codes for all of the websites for the clubs that I talked about in case you want to check them out. And that is all. Thank you. Wow.
That was amazing.
That is quite a bit. That is all. That was quite a bit. It was very entertaining. I think you have more energy now than you had back in high school. Because, man, you were just moving.
I had to drink a big coffee before this. Oh man.
No, that was awesome. Like, I'm inspired now. Like, it was really
Thank
good.
you.
Thank you so much.
Yeah.
Does anyone have any questions for Dariya? Like please, anyone at all?
Yeah, I guess I have a simple question. Do you see a lot of first people in F1? Because I've heard a lot of first people like go into F1 because it's like the same kind of like challenge, the same kind of like mindset. I expect to see like similar types of people.
Yeah, actually, like the first day that I went to a Formula Racing meeting, I introduced myself to the captain, and I came at like a really awkward time where they weren't like most of the team wasn't there. It was like two leads, and they were waiting for this other guy to show up because he was going to be giving a presentation about something that he worked on. And I introduced myself to the captain and explained that I had like a robotics background. And he was like, "Oh, I think the kid who's coming in to present has a robotics background." And I talked to him afterwards, and he was actually on the Cheesy Poofs. So I'm really good friends with him. And that was a cool coincidence. I do think there aren't a ton on my team. I've only probably met like two or three. But I think in general, a lot of students go into SAE, which there's Formula SAE where you build like a Formula style car. I think there's something called Baja SAE, which you build like an off-road type of buggy type thing. I think a lot of students or a lot of students from first end up doing that because it really is kind of like the natural next step at a lot of colleges. I tried to join the robotics team at Penn State, but it was just like a very different thing. I did meet other first students though, joining that club as well, but that club was like a little bit more programming based, and like the robots are much smaller. It's a little bit different.
Oh, that makes a lot of sense. Thank you.
No
This
problem.
also has to do with the F1 team. How do they figure out who drives it?
Oh,
Because
that's
there
a
would be people-
competitive thing. Yeah, it's a competitive decision, as it is obviously for robotics as well. But we usually have like track days where we take the car and we test it. And honestly, it can be luck. Like if you show up that day and you've been showing up a lot, and usually if you have a license, you'll get to try driving the car. And if you drive like really well, they'll notice and sort of just decide like this person should probably drive. There's never really like a formal, I don't know, there's never really like a formal discussion about it. We kind of just have these track days, and usually someone stands out. Also, there are a lot of people that do like karting, which if you want to go into F1, like a lot of kids start with like karting, and there are some kids on our team that karted from like a very young age. So they're actual like drivers, and they join the team just to do that. So sometimes it just like makes sense to go with them. So yeah, it depends on the year, but usually like that.
Cool.
Any other questions?
Oh, there's no other questions. I just wanted to add that like what what Dariya just spent like an hour explaining to you is entirely like accurate and reflective of like a typical engineering experience, like including like a lot of the life lessons like that. It's accurate. And like I feel like we try, like as coaches, try to like tell you a lot, like, oh, you'll need this later, you'll need this later, you'll need this later. And I know because I've been there that you're not going to want to listen to a coach say it, but I think that it might, I hope that it hits different coming from a former Daisy. And it's if like what she was talking about sounds appealing to you, then that's like, it's accurate. It's like that personal experience that you should really trust, and not just what like a degree program website says. So that was also like, that was great. And then I guess I do have a question. Do you actually play broomball with what was IEEE?
This is only my first year on IEEE, so
Okay.
I have not done that yet because of COVID. But hopefully I will get to next semester. Were you part of IEEE as well?
No, but I played broomball at school.
Yeah.
Except we played like the no offense, the real version where it's like actual corn brooms and actual outdoor ice rinks, and not to brag or anything, but it's way harder. But it's I have a lot of
They're
respect
throwing
for the,
shade.
Oh yeah.
I have a lot of respect
Wow.
for
No
indoor
flex or
stuff
anything.
because
Yeah.
it's different because you just have like different equipment, and it's a little bit more like everybody has more standard equipment. Like the brooms are more standard, so you have to
Right.
really work on like, you can't really lean on your broom to do work for you. You have to learn how to do it yourself. Like it's
Yeah.
so much fun. Like just sliding around the ice in like shoes is just the most fun thing you will ever do. So highly recommend it.
Yeah, I haven't gotten to play it, but every year they go to Pagula Ice Rink on campus and they do that, and everyone talks about it and says it's a ton of fun. So hopefully I get to, even though it's the light version apparently.
Yeah, it's not the real one, so don't put it on your resume, right?
No, it's the most common one because nobody, like, honestly,
Probably a commoner.
we're the only, like at Michigan Tech, we're the only ones like stupid enough to actually build 3 ice rinks ourselves outdoors and run like an entire program for it. It's a lot of work, and that's why like most schools don't have they don't have the constant cold and snow that we do. So like you don't really see it like that much outside
Right.
like the North and Midwest. But I do have a deep respect for the indoor leagues.
Really,
Okay.
Kara's league has more time on their hands to
She's
make
very passionate about this topic. Yeah,
like rinks.
I
I
almost
would
didn't
say that
include
I
that
had
slide.
not have enough time on my hands to do what I did, and I still did it anyways. But
Oh man,
Isn't that what robotics is though, at its core?
pretty much.
Right.
Robotics does give it. It helps a lot with time management, or at least like thinking that you know what time management is. I guess it gives you an introduction to time management that you might not get otherwise. And then when you graduate and you realize like all those things that you should have been doing that didn't really help you like matter as much in high school, they matter now. So it's like, yes,
Yeah.
you need to schedule yourself. You do need to remember to eat dinner, like stuff like that. And you learn to appreciate more like some of the things that you may have picked up but not actually done previously.
Yeah, definitely.
Cool.
Gosh.
Anything else for Dariya? I see you, Isha and Dora. They're our electrical team.
Oh, really?
They are. Do you have any questions, Isha and Dora?
Yeah, hit me. I
I
might not know
can't
the
think of
answer.
any questions, but it was a really good presentation.
Thank you. I appreciate it. Good luck to you guys on the electrical team, and pay like really close attention, because I was going to include this, but then I just like I didn't end up doing it because I was already talking for a really long time. But I was looking at like the FRC like diagram for like the common electronics like breakdown, and I was gonna have this whole slide where I talk about like the fact that there are so many like similarities between like the main components that you have to put on a robot and the ones that go into a car. So yeah, I didn't talk about that, but I really wish I had paid attention to that and listened to Adam when he would talk about that back then. I was just like, that goes over my head. So I would just like blank. But now I'm looking back at it, and I was looking at the whole schematic for it, and so many of those things are relevant, and you learn about, and you end up using. So yeah, if you want to go into electrical, you're getting a great head start there.
Sweet. Okay, well, thank you again so much. Once we edit this, I'll put it on our YouTube as unlisted, and you can share it with whomever you like.
Awesome.
And we'll post it so that the other half of our team can enjoy it as well. So thank you again so much. Obviously, your presentation took some time to put together. Your memories and recaps and your experiences through college were so cool. It was really nice to hear, you know, someone like talk through the different kind of like avenues you went down and then realize something else, and like the pivoting that you did, I think was really, really interesting. So thank you so much for sharing.
Yeah, thank you guys. Thank you guys for the invite and for listening. I love 341. You know, I'll always come through. You know, I'll have to come back because I had to follow up these other two girls that work for Microsoft and like LinkedIn and Tesla and all these things. So you gotta call me in a couple years when I have like a novel or something to show.
I will call you when you are, you know, working for NASA, making spaceships go up into the sky. I'll give you a call and be like, hey, remember me? Remember the team?
Right, exactly. Thank you.
Also, one thing that I completely forgot, and I'm like honestly shocked that nobody else brought it up, is Dariya came up with a cheer that we still do. It's the one that I don't even know what we actually call it anymore. Like it was like when you were on the team, it was just like Dariya's cheer is what it was called, but it's the one that like starts off really quietly with like 341
right.
341 yeah like it gets louder on that one. Like we still do that, so
we still do that.
And I think, and like obviously by your reaction, I think even like the next year you came back, you're like, God, you guys are still doing that? Like, I didn't think that was anything. And like that's because kind of goes to what you're saying about like no idea is too stupid, because we actually did it.
Well, yeah, I think I just had a lot of people that were too afraid to not do it at that point, because I had done it so many times that everyone was just like, all right, we'll just join in. It was really dumb. It was like, I think we go like yay, like really loud and obnoxiously. Yeah, whatever. I'm proud of it.
Own it.
Yeah, own it. All right, thank you guys.
All right, bye everyone.
Bye, good luck.
Thank you, Dariya.
Thank you.